Hello, hello. Uh, Good morning, students. Uh, Today's lecture, we are going to see about the AI applications in petroleum and chemical engineering. So this will be a very much interesting uh, than our traditional past developments in chemical and petroleum engineering. So this video I am posting after a long time, and I hope that you can enjoy the latest developments in petroleum and chemical engineering with the help of this presentation. So let's go back slowly. Uh, so AI is actually started off with uh, great promise in the early 1980s by the expert system paradigm in certain applications. And this is promoted by a lot of research activities in mid 1980s. But however, as the time improves, now it's a time to go and start with the applications of AI in chemical and petroleum engineering. So now let's brief in this lecture. So we are going to give in different phases like AI in chemical engineering for the past 25 to 35 years, and also you will get the background explanations, and also what is the application of data science in AI, and what the some process operations examples which are in progress also highlighted in this lecture. Now what chemical engineering has made the numerous technology advancement recently, including the process monitoring, error detection, and advanced process control system, etc. And also, what are the decisions you can make in process control? See, that also a part of your uh, chemical engineering, including your uh, safety technology, safety and hazard analysis, etc. And also, we are just describing the new technology, like I can say that large scale operations, not only in small scale, but also in large scale operation with multi disciplinary projects. So now we are seeing that lot of advancements in today's technology. We have these basic softwares like SPEN, SPEN Pro 2, DWS, CFD, Computational Fluid Dynamics, ChemCAD. So which are more impact on the next generation for especially in the chemical and petrol, again especially in chemical and process industry. And now so chemical process models which are also present the system behavior in all spaces of chemical engineering, including the research, design, and optimization control, and even plant operations. So this is your schematic of AI model. You can check it here. So all the input variables and AI model, you'll get the output variables. So whatever it may be, whether it is reactor or is a separator or vaporizer, whatever it is, so maybe input variables and output variables, which means concentration and temperature, pressure, which are the inputs, and outputs, what is your product, output variables. And now next is, so these are two types of modeling available in chemical engineering, that is mechanistic that is a approach like ANN, artificial neural work, and fuzzy logic models. So in the mechanistic approach, the fundamental, you will see the physical chemical laws such as conservation laws, conjunction, basis of the model, and algebraic equation, mass, energy, and momentum balances. So we are now discussing 8 types of modeling in chemical engineering. Next is, so what are the AI-based techniques as demonstrated in their ability, and what gives the attention in process modeling? And these techniques are well developed nowadays, like large scale language model, LLM models, or other types of models, mechanistic approach, and dealing with complex and non-linear systems. So you might have heard that basic models like rubrics and other types of AI models. And next, so the most common method is chemical engineering or the ANN, artificial neural work, and fuzzy logic, which are sometimes hybridized with evolutionary algorithms. So we have, apart from ANN, we have the fuzzy logic methods and their hybrid schemes, which are network based for a ANFI system, which is actually fuzzy interference system implemented in the framework in the adaptive networks, also applied for modeling purpose in chemical engineering. So what are the modeling steps? So you can see here the first step is, as it is see in the previous slide, that input and output variables of the system. Afterward, according to the experimental data, so we are giving the governing phenomena model. So what for the developed model, or which are going to develop. So the parameters are characterizing the A model like fuzzy sets, are using the fuzzy logic and number and the transfer functions, and also depending on the complexity and non-linearity of the system, types of variables affecting the process. So among the types of FN structures, ANN structures, the multi-layer perception MLP, also that is neural network, which has been feed forward work scheme that is used in the topology of the system modeling. So this is the mapping of input output for the dynamic processes. So in the fuzzy model, there are two types, Mandani and Takagyo Sugero TS, which are the uncertainties models, which are treated in linguistic expressions in the form of theory, is fuzzy logic. And TS is likely like ANN, commonly considered as a data-driven AI modeling approach. So what is GA? Genetic algorithm. See, the GAs can be used to optimize the performance of the fuzzy model. So maybe the use of GAs recognize the parameter estimation as well as the parameters of the scaling functions in the universe course or the MFs or membership functions. So this is your schematic model. You can see the both stuff in the Mamadani fuzzy and GA modeling system. You can see here very clearly. Step 1, you see the different variables and also optimization by GA, and also you can see the defining all the input variables and also the defining of the initial parameters of the model and also defining the objective of the function. So this is the schematic of fuzzy and GA method. So the hybrid Mamadani modeling are used two types, constructing a startup version using the heuristic knowledge, and second one is the tuning procedure using the GA. So now we can see the first step. So we are not describing more, we are going step by step. First step, all the output variables determining the behavior of the system are defined, and the input variables will affect the what are variables which you affect the output variables also determined. So after the you define the fuzzy model, so you have to go for the characterization by numbers and type of fuzzies of variables, and the process based expectation are used for the whole system. And the model is used as the startup version of the model for the tuning. So the second step, we are going to the GF formulation, optimization parameters such as membership function parameters and membership function types. So what are the applications of AI optimization in chemical processes? So this chemical process optimization has origin in linear programming in the earlier years, 1960s, 60s, and also we are defining the different operating variables in order to minimize or maximize the desired objective functions. So in general, what you will do, the objective function can be the minimization of the your operating cost and also the material production or maximization of energy, efficiency, etc., yield and operation productivity, profitability, safety, and other reliability of the plants. See now, what are the chemical processes? The nonlinear and complex solutions through gradient-based optimization approaches. So we have EAs, evolution algorithms like GA, genetic algorithm, harmonic searching, particle optimization, and categorize AI-based methods in order to efficiently define the optimization of your chemical processes. So this is the neural network system in process control. You can check out here what are the neural network, material control, plant inputs, all given. So this is the application of neural networks in chemical process control engineering. So this is only a simple schematic. So we will go for in detail later. So this is a conventional controllers cannot show the good satisfactory application in many industrial processes with non-linear because of high non-linear dynamics and parameter uncertainties. But when the AI approaches can be controlled very effectively for number of complex and non-linear processes. Because of the high potential, uh, we have handling the non-linear relationship and also self-learning capabilities of these neural networks in chemical different process such as thermal process, reaction process, separation and purification process. So one of the algorithm based neural network is the inverse model control system. So we can make use of this control variables. So this is the manipulation of the different variables controls and dynamic model. You can check it here. The function of the input and output are shown mk f5 into ysp and k minus 1, then k minus 1 tau minus k minus m tau, the whole bracket into 1. So where phi represents the function of the inversor model, k is your discrete time, and m and y are the controls actions and the output and plant and the set point controller respectively. Therefore, this diagram predicts the control action as shown in the previous diagram for the state variables and past control actions. Then we'll come back fuzzy systems which are used in different applications for chemical processes and also fuzzy logic controls and also batch polymerization reactor and polymerization processes. So now we'll come back the schematic of neural network inverse control. So we have hybrid controller based. AI strategy combines with two or more AI techniques are used: neuro fuzzy interference system, unfizz controller, and fuzzy logic. Inputs are x1, x2, and output is phi is shown. So this is the architecture of unfizz model. Two fuzzy rules for two input and one output. So layer 1, layer 2, layer 3, layer 4, layer 5. So we will see descriptively based on this what are the different layers. So first layer is named as the input layer, which says the parameter of the membership function, etc., and varies between 0 and 1. And the second layer is the neuron of the layer performance operation, connectivity operations, and calculate the firing strength of the rule. And third layer normalize the normalization process performed by the neurons of the layer. And the fourth layer is normalized fire strength is multiplied by linear combination of the inputs. Takagi-Sugeno fuzzy rule to obtain the rules layer. Then the final one is fifth layer, which the average outputs of the fourth layer. So this is the brief description. In application of AI techniques in fault detection in chemical engineering, you can see that AI failure can be described malfunctions of in the plant due to instrument failure, disturbances, and abnormal conditions, and also financial losses. So all these are monitored and used in application AI techniques. And this is the intelligent fault diagnosis techniques also used in the neural network system. So therefore, in fault detection based in neural networks, the neurons and the input-output layers are equal to the number of measured variables and the number of potential faults in the process. So this is a schematic of fuzzy fault detection system. Fuzzification, this is fuzzification, then you'll see the fuzzy rule, and finally your functional fault. So this is the schematic of fuzzy fault detection systems. So we have seen the four illustration studies: modeling, optimization, control, fault detection, and the diagnosis of chemical processes. So the disadvantage of fuzzy diagnosis is that it is more heuristic and knowledge-based rule, and also very difficult and time-demanding, and sometimes impossible for plant-wide integration process. Therefore, neuro-fuzzy direct application in chemical plants are proposed. The case study. So now we are coming back to the case study. Removal of water is a microfiltration membrane-based hybrid Momadani fuzzy GA. In this study, where Momadani fuzzy models are developed by removal prediction of two types of viruses from water. So here GA is also employed for the estimation of parameters, the membership function of the input-output variables. And the first step is defining the input-output variables of the model. You can see the amount of virus rejection considered as output variable of the models determined by this formula. Then, so the input variables of the model are consideration of the FMD virus and the consideration IBR virus, the operating pressure and volume and RPM, steering speed. So the next steps are setting your fuzzy interference system using the fuzzy sets, etc. So in this way, you are able to make the membership functions very well. The second method is in the large number of in the model. In this method, the variable of the model, all rules are considered as the membership functions. So this one is used for optimization formulation models. So this model is developed based on qualitative rules, bypassing the complexities and drawbacks of the white box modeling method and comparing the accuracy, you'll get the 90% for the developed fuzzy model. So optimization of fluidized bed reactor and oxidation of coupling of methane based on GA. So now in this study, there is optimization of C2, ethane and ethylene, and the coupling of methane over the manganese, Na2 and silicon catalyst in a fluidized bed reactor. So it's a series of chemical reaction and desired product of ethylene and over value added chemicals. And so fluidized bed reactor. So various solutions has been proposed for the yield improvement or the initiative. And one possibility to improve the C2 yield is stage-wise feeding configuration along the reactor. So you can see the section 1, section 2, section 3, section 4 feeding as per the section of the reactor. You can check it here. Not the full feed, but section-wise feeding. So in this case, you can see the variables, many process variables enhance the C2 yield which are listed, and the main GA parameters are presented and the best results are achieved in the reactor. So this is the optimized C2 yield is achieved by AI based method by 4% higher than the original modeling. So conclusion. So AI techniques provide tools to tackle complex problems, challenging the useful applications of AI, which are introduced in chemical engineering processes. So we have studied 4 illustrative case studies are we discussed here. So from this discussion, the ability of AI techniques has been revealed wide range of fields in chemical processes. So now let's come to application of AI in petroleum engineering. So here also same one and same application, but the area is different. That is oil and gas industry with multi-phase flows. So same as the literature uh, as shown, artificial neural network, fuzzy logic, and genetic algorithm, which are the most popular tools used in this. So in the basic techniques between 1989 and 2004, the number of research are carried out in using AI tools in the oil and gas industry. So we have the hybrid systems which are increased popularity, and HIS hybrid intelligence systems which are used the complex multi-phase process in the oil and gas well because of solid, liquid and gas flows, and also computational intelligent components such as machine learning, ML, fuzzy logic, neural networks, and genetic algorithms. So these are the technologies used, and also the hybrid system combining the fuzzy logic, neural network, and GA, and the expert system, which are providing the effective problem solving in different applications. So in petroleum engineering, we have interface development of simulators. Number two, well log interpretation, drill bit diagnosis, pump operation diagnosis, well test model selection and interpretation, hydraulic fracturing, gas lifting, reservoir characterization, PVT correlation, EOR project risk analysis, fluid flow in pipes and formation damage analysis, reservoir characterization, hydraulic fracture design, optimization, and oil production optimization, AOR, management, well testing analysis, drilling operation optimization, and best practice identification, optimal well design using genetic algorithm. So this is the diagram showing your models, area, and oil field asset A application. The drilling optimization. So you can see the AI-based drilling parameters, then stuck pipe, reservoir modeling, and also production, forecasting, artificial intelligence, and production maintenance. AI applications you can see in the and you can see the AI production forecast models, AI based ESP modeling, etc. So this is the another technique. Say application drilling system design operation. So this is the core objective of AI drilling dynamics and has been accurately predict the performance in the varied factors contributing the drilling process, the safety and adapting drilling practice. So here we are detecting the complexity of the operations, the downhole pressure, temperature, etc., which are misleading by the driller about the actual downhole situations, which are managed by this process. So, in the on-field success of AI hydrocarbon drilling, and the subsequent interest of the industry, the experts direct the AI techniques to adopt and improve the drilling situation with complex and non-linear certain control parameters. So these are the applications of AI in well planning, AI intelligence in well planning, so drill bit collection, mud fracture, gradient prediction, casing, shoe depth, oil field cementing, then your platform selection in the offshore wells, and trajectory and directional mapping. So these are the potential application of AI in well planning sector. Application area in drilling sector. So you can check here the diagram, well planning, also your drilling optimization, well integrity and production, decision making, operational and troubleshooting. So this is the another schematic. So important AI applications in drilling optimization. See BHA, bottom hole assembly, and BOP, rate of penetration, fracture, fracture drag, and also your weight and beat, and we have also the TS vibration monitoring estimates now hole cleaning efficiency and thrust prediction. So this is the timeline of AI techniques in different drilling practices. This is the brief table. You can check it out. And drilling optimization using AI. So Exxon Mobil, so they are analyzing the optimization of weight on weight, RPM, rate of penetration, and faster well construction, lowering the drill cost. Case study. So they are saying that AI-assisted optimization in Permian Basin. So they are controlling the high drilling cost and AI inputs. They are doing weight on weight, RPM, mud flow rate, formation data, etc., and reduce the drilling cost per well. So stuck by drilling dysfunction prediction. Field Gawar field, Saudi Aramco application, AI monitor torque, drag, vibration, and mud parameters, prediction drilling problem before they occur. So they reduced the NPT, improved drilling safety. So stuck next is reservoir characterization. Field is John's Webb field, Econar application, AI integrated seismic and well logging data for prediction porosity and permeability, better reservoir models, improved field development and planning. Then case study reservoir accuracy in North Sea oil fields offshore and IA input, seismic attributes, well logs, core data, benefits, faster reservoir modeling, improved porosity permeability, and better well placement decisions. So production forecasting. Field Kazgan field AI forecasts future oil production. The result is better production planning and more accurate reserve management. Next is ESP, electrical submersible pump failure prediction, unexpected pump failures by using the AI inputs, motor current, intake pressure, temperature, vibration benefits, failure prediction, days or weeks in advance. You can increase the equipment availability. So then artificial lift optimization, backend formation, AI monitors ESP performance, prediction pump failures. The result is reduced downtime and increased production. Then predictive maintenance. Gulf of Mexico offshore fields, companies Shell and BP, AI monitors compressors, pumps and turbines, detects abnormal vibration pattern. Result is prevents unexpected shutdowns, saves millions of dollars in maintaining costs. Case study predictive maintenance, typically industry figures, maintenance cost reduction and 10 to 40% unplanned down downtime reduction 20 to 50%, equipment reliability improvement 10 to 25 percentage. So digital twin technology field is buzzer oil field application, virtual AI model of the entire production system, real-time monitoring and optimization. So better decision making, high production efficiency. So conclusion. So we have come to end. So AI has been pointed out that it has been employed by different segments in the petroleum industry, and the applications have make huge impact at different applications, leading to the time saving, minimizing the risk, saving the cost, improving efficiency, solving many optimization problems, and also the extensive progressing, improving the drilling performance. We're using the high-tech downhole tools and sensors, modifying the classical drilling procedures by using the state-of-the-art surface rig system. So that is our conclusion, and thank you. So we have completed our lecture today. So thank you for the today's presentation, students. So kindly follow my YouTube channel. Thank you.